Hello, welcome to ANS Solver. This is the eighth question of the paper, and as you can see, it's a complex number question. So now I need to express u in the terms of x plus iy. So for x plus iy, what I do is I take the conjugate of the denominator and multiply it with the denominator and the numerator. That's how we solve questions like this. So now the conjugate of the denominator is simply 1 plus 3i, root 3i, sorry, because in the conjugate only the sign of the imaginary part changes. So this is what I can do, correct? So now I can basically write this as u equals to 4i into 1 plus root 3i, okay, over, if you notice, this is basically a plus b into a minus b, which can be written as a square minus b square. So I can basically write this as 1 square minus root 3i the whole square, which is basically u equals to 4i plus, basically I took 4i inside the bracket, plus 4 root 3i square over 1 minus root 3i the whole square is basically 3i square. Now I need to know that I square is equal to minus 1, because I know I is equal to root of minus 1. So root of minus 1 into root of minus 1 will give me minus 1. So now my u is equal to 4i minus 4 root 3 over 1 plus 3, which I can basically write as u equals to minus 4 root 3 plus 4i over 4. Now I can write this basically as u equals to minus 4 root 3 over 4 plus 4i over 4, which can be written as minus root 3 plus I, which is u in terms of x plus iy. Now find the modulus and argument of u. So what we need is, first let's calculate the modulus. So the modulus is basically the square root of the real part the whole square plus the imaginary part the whole square. So the modulus will basically be minus root 3 the whole square and 1 square. So when I do minus root 3 the whole square, I get this as 3, okay, plus 1, which gives me root of 4, which I know is 2. So my modulus is 2. Now for my argument, what I need to do is, I know u is equal to minus root 3 plus I. I'll try to sketch this on a rough graph, sorry. Okay, so I know I basically means 1, which lies somewhere here, and minus root 3 lies somewhere here. Okay, so let's say if I want to make a triangle, imagine the triangle here. Okay, this is 1, this is root 3, okay, and this is first theta, let's say. I know this is in the second quadrant, so this should be 180 minus theta, or pi minus theta, because you're writing, I think, everything in radians. So yeah, just write it as pi minus theta. So what I need to do is, I need to do the tan theta equals to 1 over root 3. Agreed, because opposite over adjacent. So when I do theta, which is tan inverse, okay, tan inverse of 1 over root 3, I get my value as 1 over 6 pi. But because this lies in the second quadrant, I do pi minus 1 over 6 pi, which gives you 5 over 6 pi. So this is basic concept, and this is basically my argument. Okay. Now, on a sketch of an Argand diagram, shade the region whose points represent complex numbers z, satisfying z, which is, so this basically means, this z basically means the center, which is 0, 0, and this is the radius. And this basically means u, which gives me, which I know u is minus root 3 plus I. So that gives me the coordinates basically as minus root 3 comma I. okay, comma 1, sorry. And as you can see, this is a perpendicular bisector form if you see this, correct? So now let's plot the circle first. I'll plot that with red. So 0 comma 0 lies somewhere here. I need a radius of 2, so there's 2 here, 2 here, 2 here, sorry, this is minus 2 here, and that's a minus 2 here. So these are basically my circle points. So I can simply make a circle something like this. Now what I need to do is I need to make a perpendicular bisector for these coordinates. So I'll use a green for this. So minus root 3 plus 1, okay. So minus root 3, if I calculate the decimal, okay, it's somewhere around minus 1.73, which I know will lie somewhere here, okay, and 1 I know will lie somewhere here. So I know one of my point is this. My other point is 0 comma 0, okay. So what I do is I know there's a line here, correct. Now I need to make a perpendicular bisector of this line, which I know will go something like this, okay, correct. Now because this is less than, I know this needs to be closer to these coordinates, correct. That means if you see the shaded area, the shift is towards this side of the perpendicular bisector, correct. But here this should be less than the radius 2, so the shift is this side now. So if I shade the area between this, that will be the area which is satisfying both the inequalities. So basic concept, but yeah, easy to solve.